Look out into the darkness. Billions of miles from the sun, Pluto drifts through the frozen frontier of our solar system. For centuries, Pluto was just a faint point of light, its true nature a mystery. In 2015, New Horizons gave us our first close-up. Now, in 2025, the James Webb Space Telescope has revealed even more. Webb's powerful eye has painted a new portrait. Pluto is more dynamic and complex than we ever imagined. The data isn't just pretty pictures, it's a new chapter in understanding how worlds work. Webb's observations peel back Pluto's thin, nitrogen-rich air, revealing the engine that drives its climate. Pluto's climate isn't simple or predictable, instead it's governed by a delicate, high-altitude haze. This haze, made of complex organic molecules, shapes the temperature, winds, and destiny of this icy world. We once thought distant worlds were static, but Pluto is alive with activity. Nitrogen ice, water mountains, and an evolving atmosphere. Webb's discoveries show a world in a delicate dance between sunlight and chemistry, where haze particles cool the entire atmosphere. Even the smallest, most distant worlds have profound stories to tell. Each mission builds on the last, transforming Pluto from a blurry dot to a world with its own climate. The James Webb Space Telescope invites us to look again, ask new questions, and marvel at Pluto's intricate workings. Our journey of discovery is continuous, challenging our perceptions and expanding our cosmic perspective. There is always more to explore, more to learn, and more to be amazed by. Imagine a climate system unlike any other. Pluto's weather is driven not by thick air or oceans, but by haze. Pluto's atmosphere is over 100,000 times thinner than Earth's, yet it has weather thanks to its haze. The James Webb Space Telescope confirmed that Pluto's climate is controlled by a unique, multi-layered haze of organic particles. These particles form when ultraviolet sunlight breaks apart methane and nitrogen, which then recombine into complex hydrocarbons. The haze extends nearly 185 miles above Pluto, giving its sky a blue tint. The secret haze particles absorb sunlight, then radiate it away as infrared heat. This process cools Pluto's middle atmosphere, acting like a planet-wide radiator. The effect is so strong, Pluto's upper atmosphere is far colder than scientists predicted. New Horizons measured this shocking cold, but models couldn't explain it until now. In 2017, Xi Jiang proposed haze cooling as the answer. Webb has now provided definitive proof. Webb detected the faint infrared glow from the haze, confirming it as Pluto's primary cooling agent. Pluto's climate is a new kind, driven by haze, not by greenhouse gases or thick clouds. It's a planetary first, and Pluto is its poster child. The universe is more inventive than we ever imagined. How can a thin haze have such a dramatic effect? The answer is in the physics of light and heat. Trillions of tiny haze particles are spread throughout Pluto's upper atmosphere like invisible umbrellas. They absorb ultraviolet sunlight, which creates them, but their main job is cooling. After absorbing energy, they re-radiate it as mid-infrared heat, which escapes directly into space. Unlike Earth, where greenhouse gases trap heat, Pluto's haze acts as a conduit, pumping energy away. This steady loss of heat makes Pluto's atmosphere much colder than it would be otherwise. The cooling is most powerful in the middle atmosphere, dominating Pluto's energy balance. This explains the temperature profile that baffled scientists for years. Pluto's haze-driven system is fundamentally different from any other climate in our solar system. On Earth, greenhouse gases warm. On Pluto, haze cools. Pluto has pioneered its own method, using organic soot to actively pump heat away. This concept could help us understand other hazy, cold worlds far beyond our sun. Pluto's haze has another twist. It helps the atmosphere escape into space. Pluto's gravity is weak, so its thin air is always leaking away. The haze accelerates this escape by absorbing extreme ultraviolet sunlight in the upper atmosphere. This heats the gas molecules, giving some enough energy to reach escape velocity and drift into space. Pluto loses hundreds of tons of atmosphere per hour, a slow process over billions of years. The haze is both a cooler and a catalyst for atmospheric loss. It creates a paradox. The same substance that cools Pluto also helps its air escape. The atmosphere is constantly replenished from below and eroded from above. Pluto's haze-driven escape highlights the complexity of even the most extreme environments. Pluto isn't just losing air, it has an active mechanism governing its great escape. This delicate balance makes Pluto's atmosphere dynamic and ever-changing. Pluto's escaping atmosphere doesn't just vanish, it paints its largest moon, Charon. Charon, half Pluto's size and orbiting close by, catches some of Pluto's lost methane. This methane freezes onto Charon's poles, forming a thin layer of ice. Solar ultraviolet radiation then transforms this ice into reddish organic compounds called tholins. These tholins stain Charon's poles a distinct reddish-brown, famously seen as Mordor macula. The James Webb Telescope has confirmed the presence of these methane-derived compounds. This is a rare example of atmospheric transfer from a planet to its moon. Pluto isn't just losing atmosphere, it's actively painting Charon. This cosmic graffiti is a testament to the dynamic relationship between these distant worlds. Even in the outer solar system, worlds are connected in surprising ways. To appreciate Webb's discoveries, we must remember New Horizons, the mission that first revealed Pluto's wonders. Before 2015, Pluto was a fuzzy blob. New Horizons turned it into a world of stunning complexity. It showed us water ice mountains, a heart-shaped nitrogen glacier, and evidence of cryovolcanoes. Most importantly, it revealed Pluto's remarkable haze, glowing blue in the sunlight. New Horizons provided the first clues that haze was a major atmospheric component, but it was a brief flyby, a snapshot in time. It couldn't measure the faint thermal emissions needed to prove how the haze cools the atmosphere. That's where the James Webb Space Telescope comes in, building on New Horizons' discoveries. Science is a relay race. Each mission passes the baton, taking us further into the unknown. Pluto's story is a testament to the power of exploration and collaboration. What makes the James Webb Space Telescope special? Its ability to see in infrared and its incredible sensitivity. Webb is the world's premier infrared observatory, detecting heat invisible to our eyes and to telescopes like Hubble. This is the key to unlocking Pluto's haze. Scientists needed to detect its faint infrared glow. Previous telescopes couldn't separate Pluto's heat from Charon's, but Webb's giant mirror and sharpness made it possible. Using its mid-infrared instrument, Webb cleanly separated Pluto's thermal emissions. For the first time, astronomers saw the infrared signature of methane matching the haze. This was the smoking gun, definitive proof that the haze radiates heat into space. Webb's achievement isn't just about beautiful pictures, it's about making impossible measurements. It can dissect light from distant objects, revealing temperature, chemistry, and dynamics. The rapid confirmation of the haze cooling theory is a testament to Webb's power. Webb lets us test bold ideas and see the unseen forces shaping distant worlds. Pluto's discoveries ripple across our understanding of the solar system and even Earth's history. By revealing a haze-driven climate, Pluto becomes a natural lab for studying similar processes on other worlds. Neptune's moon Triton and Saturn's Titan both have hazy atmospheres. Pluto's findings will reshape how we see them. Titan's thick haze is similar in chemistry, and Pluto offers a simpler test case for understanding haze physics. The most tantalizing connection is to early Earth. Billions of years ago, Earth's atmosphere may have contained a similar organic haze, created by methane breakdown. This haze could have shielded early life from harmful radiation and helped stabilize the climate. Studying Pluto today may reveal secrets about our own planet's ancient past. The processes 3.5 billion miles away could teach us about conditions on Earth over 2 billion years ago. Pluto, once demoted from planethood, is more important than ever. It's a keeper of secrets, a world of unexpected wonders, and a crucial piece in the puzzle of how planets and life come to be. Even the smallest worlds can change our understanding of the universe.